In this lesson, we will discuss the general theory behind deep neural networks, and without further ado, let's get to it. Previously, we discussed that when linear models are unable to represent a set of data, a nonlinear model is used instead. How are we able to obtain this curve? Well, what we're going to do is combine two perceptrons into a third one. To better illustrate this, we'll superimpose two linear models to form a single nonlinear model. Obviously, this linear model incorrectly classifies our data. This model also incorrectly classifies our data, although combining them gives us a correct model. This model is actually a linear combination of the two other models. Let's treat each linear model as an input node, which contains some linear equation. Let's refer to this first model as x1, and the second model as x2. What we're doing is multiplying each linear model by some weight. x1 is multiplied by some weight, weight 1, and x2 is multiplied by weight 2. And recall that we also consider the bias as a node as well, which is multiplied by some bias value. Everything is then added up to obtain the linear combination. And recall that subsequent to the linear combination, we apply the sigmoid activation function, ultimately resulting in the following curve. Now, to obtain this model, before adding the two models up, we're multiplying each one by its respective weights. The input with the highest weight is the one that has the larger effect on the result, and pretty much dictates what the resulting model looks like. In this case, the first model has a higher weight than the second one, but not by much. Although it's fair to say that the resulting model looks a little more like the first one than the second. Say, for example, we wanted the second model to have more weight than the first model. That is, instead of a weight of 1, we'll give x2 a weight of 3. That way, when we take their linear combination with the new weights and apply the sigmoid, the resulting model is going to look a lot more like the second model. Now, obviously, this isn't a very good model. It misclassifies many of our points. So let's revert it back to our first model having more weight than the second one. That way, it has more of an effect on the final result. The point being, linearly combining existing models to create new models that better classify our data is the core of complex neural networks. Even though it's your first time doing it, this should be very familiar to you. This looks a lot like what we dealt with in perceptron theory. Let's talk more about that in the next lesson.